solving systems of linear inequalities. So inequalities are going to be with the greater than, less than signs. And instead of graphing them on a number line, we're going to graph them on the 4-quadrant grid. And then we're going to shade in the appropriate sections that apply to the information here that would make this statement true. So the first one that we're going to do, this is actually, both of these are in example 1 in your book. So we're going to graph these. Now when we graphed on a number line, we had open dots and closed dots. So the difference with these is that when you just have greater than or less than, not equal to, you're going to have a dotted line when you draw your line, and when you have the or equal to, you're going to draw a solid line. And you're going to see me do that in a second. And we're still going to label the equations on there so you know which line's which. All right, so we need to figure out first what points, we need at least 2 points to graph. So if I do y is greater than x minus 2, what can I plug in? All right, so if I have my x's and my y's, if I plug in 0 for x, 0 minus 2 is negative 2. And I'm not going to flip the sign because I do not have a negative here. Okay, I do have a negative here, so we're going to have to double check that one when we do this to see which side we're going to have to shade in, and I'll show you different ways to do that. Okay, so what if I made x, let's say 2, positive 2, x is 2, 2 minus 2 is 0. So I actually have my intercepts here. So if I go from 0 down to negative 2, and then I go to 2 on the x and to 0 on the y, and remember to use your rulers because you need to be accurate, otherwise systems will not cross where you think they're supposed to. It might look like it's a little off. All right, so now this was greater than, so we need to have a dotted line. I'm going to go all the way down here, make it dashed line, or dotted, dashed, whatever you want to call it, all the way through, and we put arrows on the ends. Okay, so this one was the y is greater than x minus 2, so I can keep track of my graphs. Now the next one that we're going to do, so we have to double check because there is a negative being multiplied by this x. Is it going to be less than that we shaded in, or is it going to be greater than? So let's look at this. Okay, when we are solving and we're plugging in, because you're not moving anything right now, so it's going to confuse you a little bit. So double check, and I'll show you how to double check in a second. So if I stick a 0 in there for x, 0 times anything is 0, and 0 plus 1 is 1. And let's say I put x is 1. 1 times negative 1 is negative 1, and negative 1 plus 1 is 0. So here are my intercepts. All right, so we have 0, positive 1, and we have positive 1, 0. So we are going to, and remember this is or equal to, so we are going to angle it correctly through the corners of the graph paper squares. And remember this one is a solid line because it's also or equal to, so it includes, to make this statement true, all of the numbers on this line that we just drew, it includes that. On the other one, it's all of the ones in the shaded area, but not the ones that are specifically on this line to make this statement true. Okay, so now we have our 2 graphs. So now we have to determine what exactly is less than and what exactly is greater than. And remember on this one, do I need to flip my sign? Do I keep it less than? So we're going to double check things. Here's the best way to do it if you're not sure where things go. You want to choose a point. So let's do this one first. So you have your dashed line. And if I choose a point, not one on the line, but something over here. So let's say, here, let me do a dot here. Let's say we use that one right there. All right, so I'm doing my dashed line. Oh, I forgot to label the other one, sorry. The other one is y is less than or equal to negative x plus 1. All right, so if I choose this point, this ordered pair is negative 2, negative 1. So this is negative 2, negative 1. Remember, this is your x and this is your y. So we're doing it on this one. So if I plug in a negative 2 here, or to this one, negative 2 plus negative 2 is negative 4. Okay? do I get, and it says here, my y would be -1. So is -1 greater than, if I plug this in, -2 plus -2 is -4. Is y, or -1, greater than -4? Yes. That means you're shading on this side, and I'm going to shade on this side since I made a blue dot. I'm going to shade this side blue. So everything on this side of the graph is going to be blue. Okay, so everything over here, not including the ones that are on the line for this one, will make this true, where I put in y was -1, x was -2, and this added up to -4. Is -1 greater than -4? Yes. That's what makes it true. So now what we're going to do is we have this other line here. We need to see where it goes. Okay, so do I go this side? Do I go this side? And if you're not sure if you have flipped the sign correctly, then you can take a dot. And if it doesn't work in there, then you know it's the other side of the line. So let's try this one. Let's try this side of the line. See if it goes down. I'm going to use yellow. So that one is 1, 2, 3, 4, -5, and 1, 2, 3, 3, -5. So let's plug it in here. So if I plug in a 3 for x, that makes this -3 plus 1, which is going to equal -2 on this side. Is -5 less than or equal to -2? Or read it the other way, is -2 greater than or equal to -5? Yes. So that means I chose the correct side. If I'd chosen over here, it would not have worked. It would have said like +5 is less than -2, and you know that that's not true, so then you know it's not this side. So this is the line all the way here, so I am going to color in, and notice that that one section is starting to turn green, because this is where they overlap. This is the information that will overlap, that will have the same points for both of these equations. Sorry about the shaking of the camera there. And then these over here that are only yellow only will work in this particular equation, and these blue ones over here only work in this line's equation. But all of these in here, see how they're turning green? These are overlapping and they will work in both. So if you're solving a system, remember they have to work in both. So the points that would work would be in this green area. These would be the solutions to your system. And this is why we shade it, because you have an infinite amount of points that you could be putting onto there. Okay, so this is how you do this one. This particular one is also in your book. This is example 2. These are going to come out parallel to each other because they're both parallel, right? So they have the same slope, so that means they're parallel. And these two are different, so they're going to be in different places. So one of them is going to go this way with their shading, one's going to go this way. And remember, parallel lines are no solution, so nothing would be green. Everything would either be blue or yellow for something that is like this, where they become parallel. And this is in example 1 on the second page of example 1 in your book. Okay, then the next one in example 2, we need to be able to look at a graph, and you will have questions like this on your final. You have to be able to look at a graph and figure out the equation. Okay, so the system, solving the system is in this green. So they're going to give you something that is shaded. We have a line here and a line here. So what I can tell you is that this particular line is either going to be greater than or less than, and this particular line is going to be greater than or equal to, or less than or equal to. Okay. So when we do this, we are going to find it. So we need the slope and the y-intercept, or the m and the b, in order to get these equations. Okay, so I have definitely on this line, I have a point here and a point here. And remember, if you can't see, if they don't give you the points, wait until you go up there where it crosses in the corner of the graph paper square. And if it's dashed, they're gonna have the dash come like right at the corner so you can see it. Okay, so I have these 2 points. So this is my rise over my run. So I went up 1, 2, 3, and to the right 1. So a positive 3 is my slope. Where does it cross the y-axis? It crosses at positive 1. Okay, so what is my equation? We have a y, we have a 3 times an x, and we have a plus 1. But the question is, we know it's going to be greater than or less than, but is this greater than or is this less than? Okay, so if you're not sure which side's which, before you put the sign in, look at it. If you get confused on where they go, plug it in. So if I plug in, let's say this point, 1, 2, 3, 4, 5, 6, 7. So y is 7, x is 1. So if I put in a 1 here and a 7 here, and remember I'm multiplying by 3 and then adding 1, this comes out to be 4. And this comes out to be 7. Well, we know it's true because it's in the shaded. So is 7 greater than 4 or is it less than 4? Well, 7's greater than 4, so my sign, so this information says greater than. And when you're looking at it, it's hard to see, especially when they really have a steep slope like that. You're going, well, it's to the left, I'm thinking it's less than. If it were like this, you would know this is greater than and this is less than. So if you're getting confused, especially with a steep slope, and you don't see that it's above it, then do this process for yourself. Okay, same thing here. This is below it, right? So is this going to be greater than or less than? If you're not sure, you're going to do the same process. So this line right here was y is greater than 3x plus 1. And then on this one, we have our dot here and a dot here, and it is solid, so it means it's or equal to as well. We're going to do our rise over a run, so rise 2, run 2, so we went up and to the right, 2 positive directions. So our slope is going to be 2 over 2, which is 1. It crosses the y-axis at negative 1, because it kind of goes up 1 over 1, up 1 over 1. So it crosses there. So we have a y, we have a 1x or just x, we have a negative 1. Now again, if you're not sure if this is going to be less than or equal to, remember it's also an or equal to, so let's put that line in, then take a dot from the shaded side. So let's take this one right here to negative 1. So x is 2, y is negative 1. So if I do this, 2 minus 1 is 1, is negative 1 greater than or less than positive 1? Well, it's less than. And it's less than because it's below it. But if you're not seeing that, take a dot from the section, put it in, and what would these numbers be? Well, negative 1 is less than positive 2. And remember, because it is solid, it's also or equal to. So this line is y is less than or equal to x minus 1.